Hello and welcome to our very first episode of the series, and hopefully many more to come as we dive into some easy word problems with a lesson on divisibility afterwards. The first problem we have here is to translate 4 less than a number, in this case is x, into an algebraic expression. Obviously, 4 less than x as an algebraic expression is simply x minus 4, where we start with a variable and then subtract 4 from it. The second problem is to find the sum of 2.45 multiplied by 0.06 and 0.057 divided by 3. The equation will look something like this. First, we have to find the product of 2.45 and 0.06. Next is the quotient of 0.057 divided by 0.3. This gives us two numbers, which is 0.147 plus 0.19. We simply sum up the two numbers, which gives us 0.337. Here we are given a ratio problem where we have to find the number of women out of 350 people at a concert based on a ratio of 2 men to 3 women. First, we know the ratios, but we do not know the specific number of the groups of men and women. The x represents that number, which is multiplied by the total ratio of both groups and making it equivalent to 350. By dividing 350 by 5, we get 70, which gives a number for every group, and multiply that by 3, which is the ratio of the women, to get the total number of women, which is 210. The sum of 5 consecutive integers is 35. We are asked to find how many of those consecutive integers are prime numbers. The answer to this are the numbers 5, 6, 7, 8, and 9, with the prime numbers being 5 and 7. Now that we are done with the word problems, let us now start the first lesson, which is divisibility. A number is considered to be divisible by 2 if its last digit is 0 or divisible by 2. Here are some numbers that we will try to identify which is divisible by 2 by using the rule we discussed earlier. By first glance, 70,777 is not divisible by 2. 2000 ends in a 0, so it is divisible. 1001 does not follow the rule, so not divisible. 2384 has a last digit divisible by 2. Same with this number, and this one, and a few more here. Next, we have another rule, which is divisibility by 4. A number is considered to be divisible by 4 if its last two digits are zeros, or they make a two-digit number which is divisible by 4. Here are a few numbers. Let's just see which ones are divisible by 4. So here, the last two digits aren't divisible by 4. This one has 16, so it is divisible. This one isn't. It ends with two zeros, so yes. These last four as well follow the rules, so they are all divisible. Next is divisibility by 8. A number is divisible by 8 if its last three digits are zeros, or they make a three-digit number which is, divisible by 8. In our examples, we will be focusing on looking at the last three digits to figure out which is divisible by 8. So let's clear out the obvious ones first. This has 3 zeros, so it is divisible by 8. This one's last three digits are divisible by 8, so yes. This one also has 3 zeros at the end. Next is this number. Let me bring up my calculator here. As you can see, 768 is divisible by 8, so this one will also be considered. Let's check this one. It seems it is not divisible by 8, so no. Last is 432. We input in our calculator, and yes, it is also divisible. Next, we have divisibility by 3. A number is divisible by 3 if a sum of its digits is divisible by 3. It's actually interesting. So let's test it out. First, we look at and identify the obvious ones first. So here, for this number, if we add all of its digits, we get 15. So it is divisible by 3. If we add all of 6,781's digits, it is not divisible by 3. Same with this number. This one equals to 21, so it is divisible. This last one is equal to 17, so it is not divisible by 3. Next is divisibility by 9. A number is divisible by 9 if a sum of its digits is divisible by 9. So it has a very similar process with 3. So let's go to the examples. First, we have 1000, obviously not divisible. It's 1 plus 3 other zeros, so not equal to 9. Adding this one's digits makes it not divisible as well. This one is just 9s, so it's clearly divisible. This one as well. This only adds up to 5, so no. And adding up every digit of this number makes it not divisible as well. Next, we have divisibility by 6. A number is considered to be divisible by 6 if it is divisible by 2 and 3. So I guess there's also an interesting rule. Let's start with these 4 examples by checking if they are divisible by 2 and 3. Starting with 2, first off is 42, and it is divisible by 2. Same with 90. But with 37, it falls short, so 37 itself is not divisible by 6. And 68 is even, so divisible by 2. Next is 3. 42 is divisible by 3 here, and since 42 meets both requirements, it is divisible by 6. Same with 90. 37 is still not divisible by 3, however. And same with 68. Next, we have divisibility by 5. A number is considered to be divisible by 5 if its last digit is 0 or 5. So let's start with the numbers. Let's pick out the obvious ones first. This one is obviously not divisible. This one is divisible, not divisible, and I believe these last 3 are also divisible. Here we have divisibility by 25 if its last 2 digits are zeros or they make a number which is divisible by 25. Let's just mark this off really quick. These first 2 are divisible by looking at the last 2 digits. This one ends in 51, so no. This one is 50, so it is divisible. This one isn't. And the last number is divisible by 25. Anyways, that's the last of the rules that we will be discussing for today. Thank you for watching, and hopefully I will see you in the next video.